today we're going to talk about 9.2, which is integration by parts. So I'm going to kind of motivate this discussion a little bit. And you of course have already read this in your book, but it kind of sometimes, sometimes reading math can be hard. So let's consider the functions. So I'm just going to set this up a little bit. F of x and g of x. And I'm going to define another function. Let's let capital G of x be an antiderivative of little g of x, okay? So recall, what does that mean? That means that the derivative of g is little g, okay? Here's the idea. Integration by parts. So we looked at substitution, which was 9.1, and substitution really is used to undo a chain rule, right? So chain rule, I could enunciate a little bit. Undo the chain rule. So now what we're looking at, think of all these different ways that we could take derivatives back in Calc 1. We used the chain rule, we had the product rule, and we had the quotient rule. So really what the integration by parts does is it undoes the derivative of a function that involved the product rule. Usually it's not as simple as just the derivative of two functions multiplied. Usually it's going to be two functions multiplied, maybe minus another function or plus another function or something like that. But to motivate this discussion, the idea here is I want to know what happens when I take the antiderivative of two functions multiplied together. But for right now, what I want to do is I want to look at what is the derivative of little f of x times this function I defined to be big G of x, okay? So I'm going to do the product rule. I'm going to leave the first times the derivative of the second plus, right, leave the second times the derivative of the first. So that's the product rule. And well, anyway, I'll get to that later. And what do we know here? We know that we define this big G primed of x to be little g. So I'm just going to replace this guy with what we have defined it to be, whoops, which is just little g of x. So if you notice, I have this derivative then. And basically what I want to look for is, my whole goal here is to kind of figure out how do I take the integral of two functions multiplied together, right? We don't know how to do that yet. So if I'm looking at this integral, I know you cannot. You might want to do it, but you cannot take the antiderivative of f and multiply it by the antiderivative of g. Doesn't work out that nicely. If that was an addition sign or a minus sign, we could absolutely do that, but we can't do that if it's multiplication. So, okay, so I'm going to rewrite this over here. So what I'm going to do is I have sitting here, I want to find some sort of rule for the antiderivative or the integral of this f of x times g of x. So I am actually going to just integrate both sides of this equation. And if I integrate, I can break up integration across additions, so that's okay. Now here, this says take the antiderivative of the derivative, so they just undo each other. And then what do I have here? I have the integral of f of x, g of x. Now this is all going to be with respect to x, because these are all functions of x, times the integral of f primed, and I'm actually going to kind of switch the order here a bit. I'm going to make this g of x times f primed of x dx. And then again, because I'm trying to kind of find what is the antiderivative of f times g, I'm going to solve for f times g. And just because I have issues that we don't need to worry about here, I need to have this on the left-hand side, and it'll just make it easier eventually. So how do I isolate this guy that I want? I'm going to take this guy and move it over to the other side. And then of course I'm going to write this on the left hand side. But anyway, if I solve for this, you're in Calc 2, you see what I'm doing. Just solving for something. This big thing right here, which looks really, really, really weird, is one way that I can actually find the integral of f of x and g of x, okay? Now I know that this looks weird, and in your book, this is all they give you. They say, this is what you do, right? Here's the rule, basically. You write f of x, you multiply by the big G of x, which remember, big G of x is the antiderivative of little g. Then I subtract that antiderivative times the derivative of f dx. So you are welcome to memorize that. I am not going to teach it that way. So this is really up to you, how you're going to remember how to do parts. But one way, if you look online, try and find some videos about how to do integration by parts, or look in really any other math calculus book, you'll see a method that involves u's and v's. So this is going to look a little bit weird, but let's just trust me here for a moment. What I'm going to do instead is I'm going to let u be f of x. And the reason I'm doing this is I'm just trying to find a way to remember all of this stuff here that I have to do to evaluate this integral. I'm finding a way to remember it in a more easy way. I'm going to let u equal f of x. Okay, so I'm kind of breaking up this integral. I'm going to break this up into these two parts right here. I'm going to let this be u, and I'm going to let this guy be called dv, which basically is the derivative of some function v. Okay, now what I'm going to need a du. So du is just f prime of x dx. I'll show you why I need a du here in a moment. That looks a lot like what we did with substitution, right? Du equals f prime of x dx. That dx is important. You need to put those. And then I'm going to need actually the function v. So the function v, right, is just the antiderivative of little g, right? I have the derivative of v as little g, so the function v itself would just be the antiderivative of little g, which we have already defined to be big G of x. So now I want to show you kind of what happens here. Well, I want to, so I'm gonna. This whole left side right here, let's do a different color, okay? F becomes u, and then this g of x dx, that whole thing just becomes the derivative of some function v. And now look at what this is going to give us. Let's get some colors going. This u right here, this f of x right here is just going to be u, okay? And then this g of x right here, this big G, what did we define big G to be? V. So I have u times v, whoops, settle down there, Sarah. U times v minus the integral of, again, this is, why am I doing this? This is a very good question. This is basically a formula for me to remember how to integrate two functions multiplied together, which we are going to call integration by parts. So I take u times v minus, what is this g of x? Again, what did I define g of x to be? I have this v, the integral of v, and then what is this f prime dx? It's right here, it's that du. So this is the formula that I recommend you memorize. I recommend you use. If you, again, Google anything about integration by parts, many books are going to use this formula as opposed to trying to remember this green one right here. This is the integral of u dv minus, or equals, excuse me, uv minus the integral of v du. I had a student once tell me, well, let me tell you how I remember that. I remember it by thinking of Sunny Voodoo. And I was like, what are you talking about? What have you been doing before class here to make you say these things? Well, the reason he says sunny is UV reminds him of UV rays. So he says it's sunny, right? So that's my UV rays. And then if you just kind of mash this all up, it looks like voodoo. So we have UV is sunny voodoo. UV minus the integral of voodoo, V du. So I don't know if that's going to help you or not, but sometimes if you know little silly sayings like that, it helps. Okay, people, I'm going to do a bunch of examples. So get ready. All right, let's get rid of that layer. Let's go to this layer, and let's do some examples. So pretty simple example here. Let's look at x e to the x dx. And I want to, when you first look at these, what you want to look at is, how can I integrate this, right? Because I'm not going to tell you, integrate the following integral by parts. You need to look at this integral and know, am I going to use parts? Am I going to use substitution? What am I going to use to integrate this? So if I look at this, I see I can't really use substitution. I don't, I would normally want u to be x, but the derivative of x is 1, so I wouldn't be able to get rid of this x. So I really don't have a case for substitution. Okay, so here's what I want to do. I want the integral of, I wanted to use a different color, that's what I wanted to do. I want to rewrite this as u dv equals uv minus the integral of v du. So my goal is to somehow break up this x dx into these two parts. So here's some suggestions, okay? So some tips for doing this. First tip, choose a u so that its derivative is more simple. So what I mean by that is if I take its derivative, I want it to be a simpler function than itself. So in this case over here, look at what my options for u are. I could let u equal x, I could let u equal e to the x, or I could let u equal the entire function x e to the x. If I follow this tip here, well, the derivative of e to the x is e to the x. That's not very much. That's not more simple than e to the x. The derivative of x e to the x, I don't even want to think about. I'd have to use the product rule. That's not more simple. But look at if I let u equal x. The derivative of x, what is the derivative of x? It's just 1 dx. So that's going to be a good choice for you because the derivative of this u that I picked is just 1. The second thing, I want to choose dv so it can be integrated. I mean, maybe not easily, but it needs to be integrated, okay? So if I pick a dv that I don't know the antiderivative of, or I can't relatively easily find the antiderivative of, that's a bad choice for dv. So in this case, look at what I have. So I've let u equal x. So what I want to what is left over then for dv? Now dv must include the dx, so what do I have left over? Oh, I don't know what's going on with my pen. Hold on. Goodness. Oh, because I'm not on a pen. Sorry about that. This is what's left over for dv. So my dv then is going to be e to the x dx. So look at what I need here. I need a u and a v. I need a v and a du. I have the u. I have the du. What else do I need? I need a v. How do I find v? Well, I know the derivative of v is e to the x. So what is the antiderivative of e to the x? It is also e to the x. Okay? I hope this is making sense. This is a little tricky. All right, so I have x e to the x dx equals, again, why do I have all this stuff here? It's to help me remember the order in which I need to put things. Because if we look back at this layer, right, this whole thing right here, this is how we proved the order in which to evaluate two functions multiplied together. So that's what I'm doing right now. Okay, so I have x e to the x. I'm going to take u. What is u? It is this x, and then it says to multiply by v, which is this e to the x right here, okay? U times v minus the integral of v. So what is v? It's e to the x. And then du, what is du? Well, it's 1 times dx, which is also known as dx, okay? So again, why do I have the sunny voodoo, the uv minus v du? It's basically just a way for me to remember the order in which I need to put these functions, okay? And now my last step is going to be to integrate this guy. You do not leave your answer as this. What does an indefinite integral give you? An indefinite integral gives you a function. You should not have an integral sign in your answer. Your answer should just be a function. So we get x e to the x minus the antiderivative of e to the x is e to the x. And then I have a c hanging out. So this, my friends, can I say we're friends? I don't know about that, but this right here is the antiderivative of x e to the x. And notice it would involve a product rule. So if I check myself here, and I take the derivative of x e to the x minus e to the x plus c, I get product rule right here. First times the derivative of the second plus second times the derivative of the first, but the derivative of the first is 1, minus the derivative of e to the x, and the derivative of c goes to 0, and voila, those guys are gone, and I get x e to the x. Isn't that great? I just love that. That's so much fun. I hope that makes sense. These can be kind of tough, okay? So I totally understand if you need, you know, some extra help, or if you need to go and find other videos. I won't take it personally. If my videos aren't good enough for you, that's okay. Let's do another one. So what about something like this? Okay, so again, first thing I want to look at this and I want to see if I could do substitution. I can't. If I let u equal 2x plus 1, you know, the derivative is 2, and so I have this x sitting out there, and that x isn't going to really be able to go away because it's not the derivative of anything. I mean, hypothetically, I could take this whole thing to the fifth, FOIL it all out, and then multiply by x, but who wants to do that? So let's, again, go back to our trusty friend, u dv equals uv minus the integral of v du. Write this down a bunch. Write it down a bunch so that you start remembering it. So what am I going to let u be? I'm going to let u be x. That's always kind of a good guess, is for it to be x. Again, what are my options? I could let u be x. I could let u be this entire function here, 2x plus 1 to the fifth, which the derivative is not more simple. Or I could let u be the whole thing, which I would need the product rule, and that wouldn't work. All right, so I have u equal x. So again, this is my u. Now, what else what would that leave for dv? It would be the rest of the function, or the rest of the integrand. So dv would equal 2x plus 1 to the fifth dx. Now, so I have my u. What else do I need? I need a du. So du in this case, same thing as just dx. That's lovely. Now I need v. This guy can be a little bit tricky to take the antiderivative of, but you know, it'll be okay. Technically, I should probably do a substitution with this, and you could do some side work and do substitution, or we could just kind of think about it also, okay? So let's think about this. This is the power rule. So I know I would have 2x plus 1 to the sixth, right? And then divide by that. But notice if I take the derivative of this, I would bring the 6 down. That's great. They cancel. Take 1 away. But then remember what I have to multiply by. I'd have to multiply by the derivative of the inside, which would be 2. This guy doesn't have an extra 2 out there, so I need to divide by that 2. I need to divide by that derivative of the inside so that when I do the chain rule, they cancel. I hope that makes sense. So what is my v? Or you could just do some substitution, you know, as your side work. All right, so let's do this. So I get the integral of x times 2x plus 1. Notice my notation here. Not to brag, but I'm pretty good with notation. I'm rewriting this so I know what my math teacher knows exactly what I'm doing, right? Let me erase these, it's bothering me. I'm gonna rewrite that, okay? And then I'm ready to go. So I'm gonna take u times v. So what is u? It's x. What is v? It's this whole thing right here, 1/12, 2x plus 1 to the 6th, okay? Minus the integral of v, which again is this guy, 1/12, 2x plus 1 to the 6th times du. Du is just dx. It's not always going to be the case, but it is in this sense. So I have issues. So I'm going to I really need that constant to be first. So I'm going to rewrite that as 1/12 x times 2x plus 1 to the 6th power. All right. Leave the 1/12 and let's talk about taking the antiderivative of 2x plus 1 to the 6th. We're going to have a lot of the same stuff going on here. I'm going to add 1, then I'm going to divide by that 7, and then I need to remember what is the derivative of the inside. The derivative of the inside is 2, so I don't want an extra 2, taking the antiderivative, so I'm going to divide by 2. Plus c, I need to put the plus c the minute I do the antiderivative. So my final answer, oh my goodness, go scare some people with this. And I gotta do this on my calculator, is minus 1/168th 2x plus 1 to the 7th power plus c. And I will let you check that. That's a lovely thing about being the teacher. I've already done all this stuff, so I could make you do things. So I'll let you check that. You would do the product rule, right, to do this, and then you would do the chain rule here. This is product and chain. And then some nice stuff should happen. You should have things canceling out, you know, and stuff like that. All right, I want to do maybe 2 more, and then we'll call it good. So, how about this one? How about the integral of the natural log of x over the square root of x dx, which right away I'm going to rewrite as x to the negative 1/2 natural log of x dx. Okay. Here's the thing with natural log. Based on what we've been doing, right, we would probably assume, I mean, rightly so, we know what assuming does, but still, that u would be x to the negative 1/2. Unfortunately, we're going to be wrong about that. If we let, okay, don't write this down, I'm just going to do this really quick. U equal x to the negative 1/2. Look, well, first of all, its derivative is not more simple than it, right? That's not a simple derivative. Plus, look at what that would leave for the natural, or for dv. dv then would have to be the natural log of x. I don't know a function whose derivative is natural log of x. I know the derivative of natural log of x, that's 1 over x, but I don't know the antiderivative of natural log of x. We'll actually probably do that one. It's not too bad. All right, so here's my only option. My only option then is to let u equal natural log of x. And the thing is, it's a good option. So that's what I'm going to have for u. What does that leave for dv? It leaves these two guys. And can I take the antiderivative of that? Yeah, of course I can. Okay, that's just a simple power rule. So what do I need again? I need du. That's 1 over x dx. I could argue that that's more simple, right? Because I don't have a natural log involved anymore. And then what is v? Take the antiderivative. I'm going to add 1. That would be x to the 1/2. Divide by 1/2, and that gives me 2. The hard part about these is you're doing antiderivatives and derivatives in the same problem, kind of like substitution as well. All right, people, it's looking good. So, again, integral of u dv equals sunny uv minus the integral of voodoo. All right, so let's do this. So my u is natural log. Well, hold on. Whoops. Okay, my u is natural log. My v is 2x to the 1/2. I'm going to switch those in a moment. I don't like my natural logs coming first. Again, issues, right? Minus the integral of v, which is 2x to the 1/2 times du. Now look at what du is. It's this whole thing, so I have to put that whole thing. 1 over x dx, okay? And now let's simplify this a little bit. So I get 2x to the 1/2. Natural log of x, I just like to have that in front. Now, minus 2, I'm going to just bring that 2 out. Now, I have students here who get really caught up on something like this, okay? Don't get caught up on something like this. Remember, you know algebra. What is x to the 1/2 divided by x? Well, remember, we subtract exponents. 1/2 minus 1 is a negative 1/2, okay? So don't forget that you know algebra and you can simplify within the integral. So this is going to be 2 times the antiderivative of this, as we saw before. This is the great thing when we deal with natural logs. We actually see a little bit of repetition because you divide by that x, which takes care of that adding an x, or adding 1 to the exponent. And there's my answer, people. Pretty cool, isn't it? Ooh, sorry. That looks a little weird. But that's what I got. So that's my antiderivative. So whenever there's a natural log involved, I'm going to tell you this right now. Whenever you're doing an antiderivative or an integration by parts, excuse me, With natural log involved, you must let u equal natural log. That's the only way it's going to work. Okay. All right, one more example, and then I'm tired. I'm going to be done. I bet you're tired of listening to this. Okay, one more example. How about the integral of x squared e to the 4x dx? All right, I'm just going to show you how to do this. So I'm going to let u equal x squared. That leaves dv to be e to the 4x dx. du then in this case is 2x dx, right? I will take off if you guys do not write these dx's. They are very important. Maybe not to you, but to a mathematician. To the math, they are. And then remember the antiderivative of e to the 4x is 1/4 e to the 4x, right? It's that idea again of dividing by the ensign. All right, so I'm gonna take u times v. I'm gonna put the 1/4 first because by now you know I have issues. So I need to have that 1/4 first, and I need to then have the x squared. Anyway, you're all right with it, right? Okay, good. Minus, okay, so now I do v, the integral of v, which is 1/4 e to the 4x times du. du is 2x dx. Okay, people, let's clean this up a little bit. So I get 1/4 x squared e to the 4x. 2 times 1/4 is a half. I'm going to just bring that half out front so I don't have to deal with it. And then I'm going to put the x first as we normally write this. Okay, look at this. You are going to be so excited. Okay, maybe excited is the wrong word. To take the antiderivative of this, I get to do parts again. Yay! All right, so I have this x squared. When I have this x squared, it only brings me down to an x when I take the derivative. So what ends up happening is I have to do parts again. I have to do parts twice. If that had been an x cubed, I would have to do parts 3 times. If it had been x to the 4th, I'd have to do it 4 times. I probably won't give you ones quite like that because I don't want to grade it. So it's totally selfish. So again, like we've seen before, let's let u equal x. I'm going to do a different color here so we don't get too confused. E to the 4x dx. Okay, so I'm just evaluating this antiderivative. That's what I'm doing here. 4th e to the 4x. Okay, and now what I want you to be very, very careful with, come down here so I have a little bit more room, is I want you to be very, very careful with parentheses. As usual with your mathematics, I have minus 1/2, and then this negative 1/2, I am going to use Sunny Voodoo on this integral right here, right? So this negative 1/2 is going to be multiplied by uv minus the integral of v du. That, my friends, that's something that involves 2 terms. So I need to put parentheses, okay? So uv, put the 1/4 first, x e to the 4x. There's my uv minus the integral of v, which is 1/4 e to the 4x. Now du is just dx. So we're not going to have to do parts a 3rd time, but it got a little shaky there for a minute, huh? Okay, so let's see what we get here. So I'm going to go ahead and take the negative 1/2 through. So I get a negative 1/8 x e to the 4x. This is where it's so important to have good notation. It's important to have good notation, and it's very, very important to clearly show your work. Don't be lazy when you're doing mathematics. You need to show your steps, okay? Don't be crossing things off or scribbling things. Show each step, okay? Show each step. And then I have a negative 1/2 times a negative 1/4, right, which would be a positive 1/8, times the antiderivative of this e to the 4x, which is 1/4 e to the 4x all plus c. And so what is my final answer? 1/4 x squared e to the 4x minus 1/8 x e to the 4x plus 1/32 e to the 4x plus c. Obviously. Not obviously, not at all. And again, I'll leave it to you to check that on your own. Oh my goodness, I'm just under a half hour. I hope you are still with me. If you had to take a break in there, man, I don't blame you. I probably should have taken a break too, but you know, that was pretty fun. So work on these. Really, really make sure you do the suggested and the fun sheets. You're gonna need to do a lot of practice to get good at this stuff. And as always, please let me know if you have any questions. Have fun.